All right, let's pull back the curtain on one of the most important yet invisible pieces of the internet. It's the technology that quietly holds our digital world together, and we're going to break down exactly what it is. We're talking about Amazon S3. No, seriously, have you ever stopped to think about it? Every single photo you scroll past, every show you binge watch, every file you save to the cloud, where does it all go? So, if you're picturing a gigantic version of the My Documents folder on your computer, well, you're in for a bit of a surprise. The real system is way more interesting and honestly, way more powerful. Okay, let's get into it. The answer to our question is a service that thinks about storage in a totally different way. It's less like a filing cabinet and more like an infinite, magical locker for the world's data. On your own computer, you use something called block storage. A file gets chopped up into tiny little blocks, and your computer has to keep a map of where every single piece is. It works, but it gets complicated. S3 uses object storage. Now, think of this like a high-tech valet service. You just hand over your entire file, the whole thing, and you get a single claim ticket back. You don't know or care where they parked it. When you want it back, you just show them the ticket, and bam, there's your complete file. Simple. So that word object keeps coming up. What exactly is an object? It's really the core idea behind S3, and once you get this, everything else just clicks into place. See, an object isn't just the file. It's more like a self-contained little package. Of course, it has your data inside, but it also carries around a bunch of information about that data, and, crucially, its own totally unique ID, so it can be found in a sea of trillions of other objects. So let's break this package down into its three parts. First, you've got the data. That's the easy part. It's the image, the video, the document itself. Second is the metadata. Think of this as little sticky notes attached to the file with info like when it was made or what it is. And third, and this is the most important part, is the key. That's the unique name. That's our valet claim ticket. Okay, and here's where you have to do a little mental gymnastics. S3 doesn't actually have folders. It's a flat world. So when you see a name like photos/2025/beach.jpg, those slashes are just part of the name. The whole thing is the key. That part that looks like a folder, photos/2025, is just a prefix. It's a clever way to help us humans organize things visually. But to S3, it's all just one flat space. And that, right there, is the secret sauce to its incredible scale. So, if these objects are all the individual items, where do they all live? Well, they live inside these big, high-level containers called buckets. A bucket is pretty much what it sounds like. It's the main container where you throw all your objects. You create a bucket, give it a name, and then you can start filling it up. It's the top-level drawer in your digital filing cabinet. And these buckets have a few really important rules. First, its name has to be totally unique, across the entire planet, like a website address. Second, you have to choose a specific geographic region to create it in. And finally, the scale is just mind-boggling. A single bucket can hold an unlimited number of objects. And one single object can be up to 5 terabytes. That's huge. So we've got objects inside of buckets, but why did this model completely take over the internet? The answer comes down to one thing: reliability. An almost unbelievable level of reliability. Just look at this number for a second. That is 99, followed by 9 more nines. This is Amazon's durability guarantee for S3. We call it 11 nines, and it's a number that's so close to 100% that it's almost impossible to wrap your head around. So what does 11 nines actually mean in the real world? It means this: if you stored 10 million files in S3, you could expect to lose maybe one of them every 10,000 years. Your data is statistically more likely to outlast human civilization than it is to get lost. That's why everyone from Netflix to NASA relies on it. And with that kind of guarantee, you can see why S3 is literally everywhere. It's the engine behind content distribution, serving up the images and videos on your favorite apps. You can even host an entire website right from it, no server needed. It's the foundation for massive data lakes that train AI. And of course, for backups and archiving, it's the ultimate peace of mind. Okay, so something this permanent, this reliable, it must cost a fortune, right? Well, not exactly. S3 is actually incredibly clever about how it handles pricing, which makes it affordable for pretty much anyone. The big idea here is that not all of your data is the same. Some stuff you need to access all the time, right now. We call that hot data. Other stuff may be archives you just need to keep safe for years. That's cold data.
S3 lets you choose different storage classes, so you're not paying a premium for data you rarely touch.
And the price difference is just massive. Look at this. Storing a gigabyte of hot data might cost you a couple of pennies a month. But if you move that same gigabyte to the coldest storage, called Glacier Deep Archive, the price plummets. It can be over 20 times cheaper. You only pay for the access speed you actually need.
Now, before we finish, let's clear up two super important rules. First, can you run a normal database on S3? Short answer is no. It's built for data you write once and then read many, many times, like media files or archives, not for data that's changing every millisecond. Second, and this is a huge one for security, is your stuff public by default? Absolutely not. Everything in S3 starts out completely private and locked down. You have to explicitly say who gets to see what.
So S3 isn't just a hard drive in the cloud. It's a foundation that's built for permanence. And that leaves us with a pretty deep question to think about. We now have the technology to save information on a geological timescale. So the question is no longer can we save it, but what is truly worth saving?